Welcome, everyone. So today I'm going to talk about the project that I've been working on for a while now, which is a front end for what we call Replay 2. And Replay 2 is a FPGA platform, and I will go into more detail what that is. And for part of this front end for this platform, I've made a Demoscene plugin, and that's what I will be covering today. So first I will go into a bit of it. It's working, okay. Yeah. Okay, so I will first go into a bit of an example. So when you were to run demos today, you first you have to download it, right? Find the production, download it, figure out how to decompress it, then you have to extract the content, you have to write it to an SD card or a physical floppy. You have to boot the right machine, and you also need to have that machine that you need to boot it on. Then you need to repeat this for the next production. Then if you want to see an entire competition, then this makes it that you need to repeat this process over and over. So the goal I had with this project is to be able to run an entire competition with a single click. And part of that, you should also be able to browse party results very easily from this front end. You should be able to see production details. You should be able to just press run, and you should be able to see. And of course, as part of this, you want to be able to explore different Cines works as well. So you should be able to play music, see graphics, all that stuff in this. But before getting there, detailing how everything this works, I will go into a bit of the history of this platform. So as this platform is for Replay 2, there was Replay 1, of course. So in 2002, Mike, that sits over there, made a Pac-Man FPGA recreation, arcade recreation on FPGA, which is, I think was one of the first ones ever made. And this started the idea that you should do a FPGA board, and that was announced in 2008 with a Spartan 3E FPGA with DVI, and they had a mini ITX form factor. Then in 2012 it was certified. Then in 2015 we got our Amiga RTG working, so you could run a workbench in high resolutions. 2016 or 2017 we got so you can actually use a real 060 connected to the FPGA. And at that time Replay 2 was announced. Then in 2019 Replay 1 was shipped, and the focus was shifted to Replay 2. But as you can see now, it's that was 2019, and now it's 2026. There's a bit of a gap here, and we were a bit lazy during that time, but now we're getting really close to have a new platform to work with. And that is based on the Intel A5 FPGA, which is a very big step up from the old platform that we had. And this runs a dual Cortex A76 and A55, and it runs Linux natively. And I will speak more about these cores later, because that's very important for the front end. And as well, we will have back daughterboard support, so we can do very interesting stuff with having real chips with a running FPGA at the same time. And there will be two versions of it, which is one that we call the fat version and then the light version. And there will be 10 prototypes has been sent out for manufacturing right now. So that will be the internal development boards that we will be using to bring the entire platform up. So this is a bit more detail about the hardware. The fat version has 580,000 flops, which is a really big chip, and the light is a bit smaller. So the idea is that you can have different price classes here, but it's sort of based on the same architecture. And then we have the ARM cores, which are important for me, because that's where I do all my software stuff. So it's a duo, like 4 cores, and there's like 2 performance core and 2 low performance cores. And it runs, like I said, Linux natively, and that when you sort of start up the machine, that's the front end is what I'm doing, is what you will see directly. Yes, so we will bring back the 060 support again, and have like a detailed like board layout view, so people can do their own hardware extensions for this board as well. And something that we're actually thinking about doing is like an Amiga chipset board. That is, the idea is then that we can use this to verify the Amiga FPGA core that will run on the platform, so we can see if it actually matches the real hardware in a very good way. And the other thing that is very important that some other platforms like FPGA platforms lack is that you can't have several cores or systems at the same time, but this platform supports that, so you don't actually need to like re-flash the entire machine if you want to run something differently, which is very important for my work. Because for the Demoscene launcher, you want to be able to switch between platforms very fastly, and you don't want to like reflash the entire system, right? Target platforms. So we plan to support many arcade systems. Of course, Amiga, many of like the NES, SNES, Game Boy, GBA, etc. So, and we're not really sure where the high end is at. So definitely N64 and PS1 era will be supported. But I hope to go beyond that. Exactly where that is, we are not really sure yet. But we'll see what happens there. Hopefully we see that this platform has a quite long time span, so we can expand on that as well. So just the raise of hands, how many here knows what an FPGA is? Around half, okay, that's good. So, so what is an FPGA and why does it actually matter? So you can see an FPGA as a sea of configurable gates. And why is that a good thing then? So the idea is that if you have a design for like a hardware chip, you're able to like recreate that very closely to how the original chips worked in hardware, and you can have all this implementation very accurately to the original hardware compared to an emulator. But of course, there are some downsides to it. Well, development cost is higher and it's more expensive. And the thing is that it's a bit more resource constrained, and the learning curve is a bit higher. But the way I see it is that FPGA is not better or worse than emulation. You can have an FPGA implementation that is bad and an emulator that is good. But I see that this is a different approach. But I think going forward, the FPGA will, at least in our case, be very, very useful and try to bring as most accurate representation of the platforms as possible without using the actual hardware. So now I will go into a bit on how the actual front end works and so the things I need to do to make it run fast. So it's written all in C11, so C. Minimal runtime, I have no GC, no hidden allocations. The reason I chose to use C, it's very predictable, it's a simple language, it's well understood, and many people makes it easier for people to contribute to the code later. Around now, it's around 100K lines of code, which is a lot. It's something that I would like to try to bring down a bit, but that's sort of where it sits today. Another thing that I made that is a very conscious choice was to make it very plugin driven. What I mean by that is that I have different types of plugins. So one plugin type is like for UI, for example. So I have a music player, the demo browser, slideshow. So that's all plugins. Then I have something which I call BFS plugins. And that is so you can load data from different sources, but the API from the user's point of view is all the same. So you can load from zip files, you can have zip files inside zip files, and you can load them from HTTP or FTP and stuff like that. It just makes the user side easier. But also supporting different decompressors makes it easier for people to say that, oh, this different compressor is not supported. You can do a plugin for it directly and extend the front end without actually us needing to do some extra code for it. Another thing that is what I call the metadata plugins. For example, the Demozoo database sits here to provide like all the data that you sort of need for do searching, stuff like that. I also have Modland to search like the entire Modland repository for songs. So that's another metadata plugin. So that sort of makes it that you can bring in more games, the SID collection, etc. So you can add more stuff like this to use as well. Another thing that I spent a lot of time on is the job system and how the threading works. Something that I find super annoying when I use like Apple TV, Netflix, and all that stuff, they are all laggy. Even if they have the like super powerful hardware, it's laggy when you scroll and all that stuff. And in my case, it should be 60 FPS, not a single frame drop. That's my goal. So the way I've done it is that I have a main core that is doing all the rendering and just set up the basic stuff. And then I have 2 worker cores that sits on the efficiency cores. And that is doing all downloading, image loading, unpacking queries. So when you're searching for something, there is a job that gets spawned on one of these workers, and then you get a sort of a handle back, and you check if it's done or not. And then if it's not done, you sort of do another update loop, and then you check again. And if the result is there, then you do something with it. So there's never any blocking going on. And this is true for all I/O. There's like no I/O at all, like file loading being done on the main thread. Another thing is that is important is that I have a priority system as well. So if you are loading some images or downloading something, they have different priorities. For example, if I'm updating a database for like Demozoo, it might not be very needed exactly right now, so that can be like a bit lower priority. While if you're browsing some scene page or like a party, for example, you want to see like the preview images as fast as possible, or if you start playing something as fast as possible, so that gets loaded up to a high priority. So that's the idea, is that UI should always stay responsive, nothing should block the main thread. So the other thing then is like, how do you design a UI system for this? That's, so what I do, I use something called Clay, which is a C library to do layout. And it's very, very basic, but it's very powerful. So it's a layout engine, and what it do is you allocate all memory up front. So there's like no allocations during the runtime. And then I have like a very tiny, small wrapper on top of it just to make the API slightly nicer for my use case. And then I add like a widget library on top of this. That's your standard stuff that you expect. Is buttons, text, images, slider, drop-downs, all that stuff, right? And there's no retained state here. It's all rebuilt every frame. So the frame pipeline sort of looks like this. You have your button, you have a layout engine, and then you convert this to a bunch of render commands, and then we have the rendering phase that I will detail a bit more. So the constraints then is that I have no GPU, it's only CPU rendering. I'm targeting 1080p, so it's around 2 million pixels per frame that I need to draw. And 60 FPS mandatory. A frame drop is a bug in my world. Other thing is that I still need to support PAL resolution. So the idea is that people will also connect this to CRTs. So it needs to be able to scale down. The PAL support is not like a problem in itself because the resolution is lower, right? But it still needs to be able to support this and look good. So that's the problem, right? You have 16.7 milliseconds per frame, 2 million pixels. You have no GPU, so you sort of need a strategy to render this in a good way. So the way I decided to do it, I did a tile-based architecture. The idea is that you split your screen into tiles. Then you have different phases. So you have one phase, which is doing binning, then rendering, and output. And I will go into detail on how all these works. But first is that I decided to have a 64 by 64 tile that fits very well into the level 1 cache. So the entire rendering stuff like that fits very good. So I just reuse the same area pretty much. So the binning phase it's very simple. Is that when you sort of look at all your render commands, and then you need to figure out which bounding boxes does a rectangle, for example, touch. In this case, we see that this rectangle here, that is some button or something like that, touches 6 tiles. That means that each tile has a list of IDs into the big buffer of render commands. So each frame I build up this ID list. So that means that in the end, we just have a compact list for each tile of what I need to render. So the actual rendering then. So the tile is that I have a tile, then I've walked the entire command list per tile. I figure out what needs to render, then I need to do all the clipping and all that stuff. That's kind of straightforward. I also have a special fast path if the case is that you fill an entire tile with just one thing. You can sort of skip lots of the extra setup and just write it to the output directly without writing it into the tile and then back out. So that sort of accelerates it a bit in some cases. And then the other thing is that I have what I call render permutations. The idea is that when you want to render something, sometimes you have blending enabled. You might have rounding on your buttons. And you may have a gradient enabled to do fading. So what I do is that I have a list of these variants. So depending on what I want to render, I jump to the correct version, because then the entire loop can be fully branchless inside it. So that makes the code faster, and it just makes it easier to reason about it. And so I actually always investigate how these loops look for all of these cases, and I just want to see a clear loop with SIMD instructions, and there should be no branches in the hot loop. The other thing is that what I do is that I have a planar buffer. So people coming from the Amiga knows bit planes. What I have is byte planes. So I separate out all channels into R, G, and B channels. The reason I do that is because when you're using SIMD and you deal with RGB values, that doesn't line up very nicely. So it becomes very annoying to deal with that, because you usually want to have 8 or 16 values to process at the same time. But if you're splitting it up into this structure, you can load in all the 8s, all the reds, and all the blues once instead. So then we go to the output stage. So we have this planar layout right now. But then we need to still write it out to the frame buffer, and that has an interleaved format. But thankfully, this is actually very simple on the CPU that I'm targeting, which is the ARM. It has very nice SIMD instructions to do this. So all I need to do is to load up the data, and then you do a shift down and to pack them. And then there is an instruction that actually stores this data out directly interleaved to the frame buffer. That instruction is perhaps the fastest of them all, but it's super easy and it's well within the speed that I need. So yes, no manual shuffling is needed at all. Usually when you need to do cases like this, at least on like x84, is that you need to like shuffle things around, merge them together. But yeah, it's really nice that ARM thought about this case. That is very common, so there's no need to do that on the ARM. All right, so now we're getting into closer to the actual Demoscene stuff. So what I decided to do is I used the Demozoo database for all the data related to demos. And the number of releases here is a bit scaled down. I have excluded Windows, which we likely will not support, like modern PC demos, right? But there are like still tons of releases. And yeah, there are like many releases, and there are like tons of parties that you sort of can go through in this database. And the important thing then is how do you take this data and make it fit into memory? Like, even if we have like a bunch of gigs on this device, you still want it to have as small as possible. So what I do is that I take the Demozoo's Postgres database and I convert it to binary format instead. So I load it up and then I build a bunch of lookup tables to make this sorting much faster. So that means that you always have the database on the machine at all times. And then I have something that builds the database daily and uploads it to servers. And so when you have your front end running, it will check like each one day if there's a new database, and then you can just download it in the background and swap to the new one without the user noticing anything. So going into how I sort of design it. So first we have this start page. And it works similar to how you will see like on Netflix or Apple TV and similar TV applications, is that you have a bunch of like new stuff, you maybe have some old series and stuff like that, but in our case we have demos, which is like I sorted by era and like famous groups, winners from different parties, and the way the navigation works, which I will show, is that you sort of navigate down and then you can navigate on the row. It sort of works very similar to how you do any of these applications today. And of course, I also include music and graphics, which I think is a very important thing as well. I think in many cases, and that's something that I have always missed from Poet, is that they still don't include graphics and music, right? So that's something that I want to have in this as well. Then, of course, searching is very important. So right now I'm working on a more advanced search. But right now I have something basic up, so you can just type something and it will search for that. And the search is quite fast. Because the database is local, it means that you don't need to go to the server to do the searching. And that's something that I made as a conscious decision, because there is a REST API for Demozoo. But this way I can control exactly how the search works. So I have a fuzzy search, for example, so you don't need to type exactly what you want, but it will still find something. But yeah, so right now you can have productions, you can filter by graphics, music, parties, and with the advanced search is that you can do per year, per platform, per competition. There are lots of complexities to designing the search in a good way that will fit most use cases. So I just try to first keep it simple and then try to do the advanced stuff. Testing out how it can actually work. I think that's something that sort of needs a lot of testing, but I think the first thing works fairly well. Then, of course, production pages. That's very important. That's where you see the details on the production, and it's platform, name, and the group or groups that made the entry, and then which part it is, and all of this like blue text here, you can navigate to those. So if you want to know about Jesper Kyd, for example, you can just navigate and see all his releases. And something that I also do here is that you should be able to run directly, right? But I have also, if there is a linked soundtrack, you can also play the soundtrack. Yes, and here we have releasers scene pages. So that's also similar to the other things, is that you show the member, which group the release is a member of. This view is very similar for a group as well, then you can also filter. So if only wants to see demos or only musics. So for example, the idea is here that you can select music and then press play at the top right, and you should be able to play all the music. That is supported. Of course, party pages are very important. And here I decided to do it like this, that even if there are some competitions that is not supported directly by the hardware, I still want to show highlight them here. So what happens if you navigate to like a PC demo, for example, it will say unsupported platforms when you try to run it. But I still think it makes sense to do it like this, because for example, 4K executable graphics, I can't run that on this platform. But I can still show all the screenshots from them. So I think that's still valuable. Another thing that I find very important is to have good music playback. So I have right now supporting 28 plugins, and I think these plugins cover around 600 formats or something like that. Because many of these formats, like UAD and OpenMPT, for example, support more than one format. So libopenMPT supports mode, impulse tracker, XM, etc., etc. And UAD, which is for supporting Amiga format, has a big range of formats that it supports. So the idea is that when you want to play something, you should be able to, if the music player supports it, you can just press play and it will play it. Something that I really like as well is pattern displays. So I've done a bunch of like different pattern displays for different formats. So to the left is Pro Tracker, then in the middle is like XM and IT. Then I'm also working on pattern displays for SIDs, which is almost an entire talk by itself. But the short version is that what I do is that I, on like a server, I play back all the SIDs and look at all the hardware writes and do filtering on them to write out like approximations of the commands that are being played. The problem is otherwise, if you just show the register writes to the hardware, you will get tons of writes all the time. So this is sort of an idea to filter out the writes and have something that looks similar to how it could have looked like when you composed it, for example. But it's very, very finicky to get right, and I'm not there yet. But it's promising, and that's something that I'm working on. Yes, of course, slideshows is something that is important as well. Is when on a competition, you should be able to just press play, and you should be able to see all the graphics competition, and it's just cycled between them. And there is the way I've done it is that the first page states the name, the author, and also different tags, which comes from the database of Demozoo. So it can say, for example, if it's a 320 by 200 and it's in 16 colors. So I don't extract that info myself because I use the PNGs. And they can be in 24-bit format, so I don't know that. But it's easier to do it this way, to use the tags, I think. So that's why I've done it initially, at least. one way to like extend this would be to try to actually download the original archive and try to figure out what the actual depth is and stuff like that. But yeah, it is complicated, and I will get into some of the complications you sort of run into when you try to look at files that is just has no structure at all. And that's what we're getting into now. So this is one of the more like tricky things about running demos in general, I would say. Each thing in itself is not complicated, but it's like just a range of things that makes it complicated. So, for example, is that usually you have your one download link for one production, and it has one executable in it, then it's fine, you just start running that, right? Or if you have for Amiga an ADF file, then it's all easy. Then you just run. But if we go into a bit more detail, we can see that it's not as straightforward. So first you have like lots of various different compressions. Right now I support like LHA, DMS, ZIP, 7-zip, RAR, LCX, and a bunch of more of them. But there are tons of more that likely needs to be supported at some point. So what I've done now is to mostly focus on like a smaller set of platforms to just get something up and running. So I'm focused mostly on the Amiga and the C64 to begin with, and I also have support for some console platforms. But the idea is that it needs to be expanded, but many of these problems exist on other platforms as well. But yeah, the archives within archives is a fun one as well. So you have a zip file that has a zip file in it, and then I think I have, the worst case was 3 layers with zip files, and then to figure out which executable to run. So those are like fun. And also other things is that you have unreliable download links. So I try to sort them, like giving a priority, for example. So links for Modland usually works really well. So for music, I prioritize them higher than the other ones. Then Dropbox links can be really annoying because they might actually show you like, if you click here, then you need to press this button to download something. So I try to not use them if I can do that. Of course, other thing is that when you have downloads, you need to handle timeout and partial downloads and all that stuff. It's lots of churn and stuff around it. This to get it working without isn't actually just running demos. So need a fallback strategy. Just take the next download. In many cases, Demozoo actually have multiple mirrors on each entry. So I try until one works. That is usually fine, but it's not the best experience. So this is something I also want to try to make a bit better. So, for example, one way would be to just try to download everything from Demozoo and see what's the better way to prioritize this. Another thing is that you can't trust file extensions. That's a fun one. So the best thing is that you need to do content signature detection. For example, there's been some cases when I downloaded like an Amiga intro, and the executable was named .txt, which that's a very rare case. But what I try to do then is to actually look more at the data at the beginning of the file and say that, okay, I know that this is supposed to run on the Amiga, so we look at the signature that see, okay, this looks like an executable. We will try to run that. And that goes into this auto detection versus meta-platform hints, which is, there is metadata from Demozoo, but in many cases you sort of still need to verify the content, which is, it's not great, but you sort of have to do it. Of course, going back to update some entries is what I've actually done on Demozoo in some cases, but yeah, it's tricky. You can't just go and like repack all the demo data pretty much. So you sort of need to handle cases like this. Another thing is like multi-disk handling is that people, when they name their disks, it can be tons of like different variations of how that this works. And when you want to run a demo, you need to have the files in the correct order. So you sort of need to do lots of fiddling here to just get it right. And each of, like I said before, it's like each of these in itself is not hard. It's just a lot of things that you need to get right to get everything working. So another thing is that something that I'm working on as well, which is a bit work in progress, is that auto-swap detection. So if you have a multi-disk demo, I want to be able to, so you don't actually need to swap disks at all. So I tried a bunch of like various ways to implement this for C64 and Amiga to begin with, because yeah, lots of multi-disk demos are on those two platforms. So there is like different things to just monitoring what's happening on the drive and see if, for example, if the demo is trying to read the same track over and over and over, it's likely a hint that it might be looking for the next disk, for example. But this is like a research thing that I'm working on as well. I have it working for some demos it doesn't work, so I think I need to figure out something that is a bit more lenient. But at the same time, it should not break. But the idea is that you should be able to, again, just run demos without need to think about this. Other thing, of course, for the Amiga is that many demos needs more memory. So how do you figure that out? Because there's no metadata that tells us what we actually need to run a demo. So something I've been thinking about is that I should just download all the demos and try to run them on an emulator and to build a database to use that going forward. And so it will make it possible that I can have this inside my own database and say like, okay, start up, and then I know exactly what needs to be done and with the memory configuration that is needed. But yeah, then the open question is, how do you actually detect when you're stuck, crashed, or stuck on a black screen? So there's a bit of like complication here on how to detect this as well. So, but yeah, this is something that I need to look at as well. And this is for like Atari as well. So yeah, fun things to sort out pretty much. Another thing that I'm working on that is to do a new Amiga room for legal reasons. So one problem, if you want to run your, usually when you want to run an Amiga emulator, you need to download a Kickstart, right? And the Kickstart has to come from your machine, right? But usually you can find it somewhere. But the idea here is that we want to be able to ship a ROM that you can just start running, so you don't need to download something. So the idea is, yeah, why not just ship with the real Kickstart? That will be very easy, right? But they are still copyrighted, and when you ship a box with something, that becomes a bit more complicated. So the idea is to try to do something that is aimed at demos and games only. The idea is that then you can slim down what you actually need from the operating system or the Kickstart to actually run stuff. So the idea is that what you do in like an HLE approach, which is a high-level emulation. So you implement all the API calls outside of the FPGA core, and the idea is that you don't need a full operating system. So I had my friend Ralph run around over 4,000 demos to figure out what libraries from the Amiga do they use. So exec library is it's a very base library for the Amiga, which pretty much everyone will use. So that's a given. And the top calls for exec library here is like allocmem, freemem, forbid, disable, stuff like that. But the idea is then you can start implementing this a very small subset and still be able to like run demos and games without needing to have a specific Kickstart. And I think that's very valuable. The other thing is that it will make it possible to start the games even faster as well, because you don't need to do any memory checks that the Kickstart is doing now, for example, because we know the hardware, so we don't need to do anything of that. All right, so now let's show how it actually works. Sorry, I will not. I will still stand up. Okay, so here's how it looks. So you navigate like this. Basic stuff. And then if you can go like this, and then you can press run. So this is how it works. Very basic, straightforward. And the idea is that, yeah, this should work for very much the same for all platforms. And you also have this play soundtrack here. And in this case, there are like two soundtracks. There is a startup soundtrack, and then the real soundtrack comes. So you have some shortcuts here where you can switch over to the correct music directly. And in this case, I made like a ProTracker-like pattern displayer. It's not exactly ProTracker, so I just slimmed it down. But you can sort of see what the idea with it. Then you can navigate back. So more, for example, yeah, we can try this demo. See if it runs. Yeah, the internet is a bit slow here, so yeah, so this is sort of the main idea behind it, that you should be able to run anything in a simple way. So let's try this one. So this is a C64 demo, and it has a disk swap in it. So it will tell you right now to switch disk, and it will do this automatically. No. Yeah, we don't need more. Play soundtrack will also work. And here you can see the pattern display as well for the SID. And at the bottom, I also have like a timeline, like similar to sort of how the SoundCloud works, for example. I don't think it's fully accurate right now, but it's sort of the idea that you can have all this like timeline and see how everything looks. But yeah, do some more stuff. Let's search for a party here. Let's search for a girl, for example. So here's a party, and then I can show you how it looks like. If you want to see like a graphics competition, you press on the first entry, and it will show all of them in row. So it will state the author, show the image, fade it down, show the next one, name of the first one, of the next one, and then fade up. And a similar thing for music competitions as well. So the idea is then to start playing the music, and while now it's playing this song, it will download the next one in the background. There is something weird here, but it doesn't lag on my machine. Yeah, so then you can switch to the next tune, and the idea is that it will auto-switch if you don't switch to the next one. So you can play an entire competition this way. So the next question then becomes like, what is I'm actually showing here? Because I'm not actually showing on the real hardware, right? So the thing is that we don't have the real hardware yet. So I implemented this to run on PC and in this case a Mac. And then I added a bunch of like emulators like vAmigans and Vice, for example. So I just have something to test with. But the idea is that on the real hardware, this will look very much identical. Sort of behaves the same way, and it should run in a similar fashion. Do I have some? Yes, so the idea is that you have a bunch of competitions here. You can just scroll down, select another one. Yes, here is a bunch of graphics competitions as well. So in this case, we have a 4K executable, but I can still show the images even if I can't actually run the executable. So that's something that I feel is still better than not being able to do it at all. So here is like the recent graphics that's been uploaded. This one is, if you don't know, this one is by Virgil. I was supposed to release it here, but couldn't because they couldn't use old school platforms in the 4K executable graphics. See if this works. Yes. This looks weird. So that is sort of the idea. There are still like lots of things to add to be supported, like different platforms. And so what I have now, I have support for some consoles, for example. So we can see, we can try so we can go, when you scroll up, the way is simple is that you just scroll out to the page and then you can start searching. So we search for. So this is a Super Nintendo demo. Yes, that is sort of the basis how it works. Wrong direction. So that's, that we looked at that. So then now come a bit about timeline and roadmap for the actual project. So we have sent that prototypes to manufacturing. That's where we are now. This is a bit of a challenge for us, like the memory supply and what the price will actually be when we get that. And we don't know yet. So the idea is that we will build these prototypes and start from there, see where it goes. So that's it. Thanks. Any questions? If you have questions about hardware, Mike sits over there. He will tell you everything. Yes.
Say I wanted to make a demo with a custom core. Would that be possible to use the platform with a custom FPGA core?
So, can you repeat that?
If I wanted to do a demo with a custom FPGA core, would that be a viable platform?
Yeah, absolutely.
But I would have to make two cores, I guess, because you have two different boards.
No, we will have two boards, but you don't only need to make it for one, unless it's very, very big. So you need all the space for that's in the large one. Otherwise, if it fits within the smaller one, you can do it just for one.
Right. Okay. So the bigger one can use the same bit stream. Can it use the same bit stream? No. Okay, thank you.
Crystal clear. Right? Well, thank you. If you have more questions.
What will be the price?
Sorry?
What will be the price of the board?
We don't know.
You
The
don't know.
problem is the memory prices is a bit tricky one because they went up a lot.
Yeah.
So we need to source. The problem is that you need to source like a big batch, and then you can get the prices down. So we need to figure out what the sizing is, and when we do it, because right now we first want to build the prototypes, right? And then we need to figure out how many do we need to bring to production, how many do we think people will buy. It's a tricky balance. So unfortunately, I can't say price yet, but I wanted to be able to say that, but I can't do that yet.
I'm really interested to have that at home too.
Okay.
Show it at friends to see what the Demoscene is, what demos.
Yeah, that sounds good. Yeah. All right. Thank you.